So we're going to start a unit called data collection, and today's topic is populations and samples. Sounds good. Okay, the first thing I want you to do is look at these 6 words and try and write definitions for them. Just give it your best shot, okay? Don't be lazy and think, oh yeah, I'll just think of the definitions. Go for it, and then you can see how close you are with mine. So pause the video and have a go. Okay, because your definition of population might be different than what I'm looking for, but that's okay. That sort of would start a discussion point if we were in a classroom together and etc. Um, so population in terms of statistics is actually a collection of individual people or items. It doesn't actually have to be people. It could be sports equipment, and that's what you're interested in knowing whether it functions properly or not. All sorts of things. Could be shoes and whether they have holes in. How many shoes that are made in a factory end up being not very good, for example. But it could be people as well. It may be infinite in size or finite. We'll look a bit more at that in a minute. Okay, a sample leads on from this. A sample is a subset of a population. So we've got the whole population of shoes, and then you might just look at some shoes right here. Census. You may have heard of the word census before. Typically, in each country, a census is done every 10 years. It might vary on country, and that collects data on everyone. So every 10 years, and there's a reason for that, which we'll talk about. But it is an investigation in which data is obtained on all members of a population. Note, it might not be all people. It might be all your shoes. You really want to know about all your shoes, for example. Sample survey, same sort of thing, but now you're doing an investigation about some of the population. So again, we're back to just wanting to know about these shoes. And probably the 2 most tricky ones to remember, okay, but actually, there's a fancy name for them, but they're not exactly, difficult concepts as such. A sampling unit is just the individual units of a population. Guess what it is for this one over here? It's an individual shoe. And then sampling frame is a list of sampling units from a population so that all units are known. So this is me listing all my shoes. I got a bit carried away with shoes, but it illustrates these ideas. Okay, now coming back to this idea of an infinite or finite population. If it's possible to count the units in a population, then it's called finite. Otherwise, it's called an infinite population. Note this is slightly different than the idea of infinity in pure maths. Infinite in pure maths means we can never reach it, whereas an infinite population, well, we can actually have a finite amount. It's just that we might not be able to count them. Okay, so you'll try and get your head around that. But actually, I think the best thing to do is look at some examples. So we've got 12 little, I want to say statements, 12 little cards that are they either fit under finite population, infinite population, or sample. Now, actually, I've designed it so there's 4 in each. You might disagree. What I want you to do is try and think, is this part of a finite population? Is it part of an infinite population, or is it part of a sample? Let's just remember again, a finite population means we could count it, okay? It might still take a while, all right, but we could do it. Infinite population would mean, well, it's going to take a ridiculously long time, probably not possible, or it is in fact infinite. And a sample is going to be just a little small collection of shoes, for example. Okay, give this a go. Give it your best shot now. Okay, this is what I went with. Let's see if you agree. You might disagree. So, sample. Okay, here you can see I'm taking a selection of people. I'm taking every 100th card, 10 people's questionnaire in a magazine. Not everyone in the magazine is going to be asked, because only some will fill it in. Finite population. Okay, you can deal with the pupils in a school. That it might still take a fair bit of time, as with hospitals in Wales. People in China. Okay, there's over 1 billion people in China. That's going to take a while to ask them everything, but it is doable. Cans of soft drink produced in a factory, you could look at all of those. Infinite population. Now this this might get you being like, no, I'm not happy with that. But ferns in a wood, okay, it's going to be very, very difficult to look at every single fern in a wood. You might argue that it is manageable, just like it would be to ask everyone in China, but I think it's definitely more challenging, to be honest. Grains of sand on a beach, okay, how can you look at every single grain of sand on a beach? You can't, can you? Rational numbers between 0 and 10, this is actually one that is infinite. If you could write down as many as you want, I could always come up with an extra one. You can't look at every single one. Number of telephone calls made in a year throughout the world. Again, how could you possibly investigate all of that? So you might think, you might disagree with some of these, okay? And that's kind of I think this is part of the interesting bit, to be honest. But I wonder, at the end of the day, I think I can justify why I believe they're like this. And, a little mini task, can you think of some more? Non-trivial examples. Don't just say, oh, every 90th car taken from a production line. Can you think of some interesting examples that would go down here? Okay, we're going to return now to two keywords from before, the idea of census and sample survey. Remember, a census was when we got data on everyone in the population, and a sample survey was when we just had it on some people. So my question to you is, what are some advantages of taking a census and what are some disadvantages? Now pause the video and have a think and write some things down. Don't just like play the video and wait for me to tell you. Go for it. Okay, some advantages of taking a census. Well, the first one is that it does exactly what it says on the tin, really. Data is collected on everyone. And that could be a really useful thing to have. It's unbiased. That means again, that links to the first point, really. You're not just going to have views on a few select people, maybe people with extreme views. You've got data on everyone, and it gives an accurate answer. I mean, you're going to have full data on everyone, provided they've been telling the truth, of course, but that's another issue. Some disadvantages. Why don't we do a census of everyone in the UK or somewhere every day? Why not? We get data on everyone. It'd be great. Well, no, because it takes a long time to do a census, or a longer time than to do a sample, which we'll see in a minute. It's going to be costly in general to ask everyone in the country about all sorts of different things. That's going to, and then process it all. That's going to be costly, and it's often going to be difficult to ensure that the whole population is surveyed. For a census of people, then you might have people living under the radar. You might not have a social security number or something like that. National insurance in the UK, I should say, that sort of thing. But other things as well, where it might be difficult to actually get to everyone. People might not answer as well, but again, that would be a different question, because if they're not going to answer to a census, they may well not answer to a survey as well. Okay, a sample then aims to be representative of the whole population. Yeah, you're not asking everyone, but you kind of want to have everyone's views. So the advantages and disadvantages. Off you go, have a think about this. Okay, advantages. Well, it's generally going to be cheaper if you're only asking some people rather than everyone. If the testing of items results, there's a slight misspelling there. Okay, why am I highlighting it? There's a slight misspelling. That should be, if testing of items results in their destruction, then sampling makes tests feasible. Okay, let me explain that. So let's say we're testing seat belts, okay, and we're testing at what strength we have to apply, what force you have to apply to break them. Well, if you do a census, well done, you've managed to break every single one of your seat belts. If you do a sample, obviously you can't just test one, but if you test a good sample, then you can get a good indication of all of your seat belts without having broken them all. Okay, so that's more important than you think. That is an important one. And when using a sample rather than a census, data is generally more readily available. that's kind of depends, I think, but you're gonna you're gonna be able to. It depends on what type of sampling you're doing, to be fair, but it is going to be easier to get to people like a smaller number of people than a larger number of people. I think that's what it's getting at. Some disadvantages. Well, there's going to be uncertainty. Two different samples will have, we call this natural variation. So any sampling you do, if you then did another one, you're going to get some differences. That's just due to natural variation. You can't really eliminate that. And the issue is that you may get a biased sample, which means it does not represent the population. That is not good. Bias can occur from making the questionnaire optional or voluntary. We're going to talk more on different sampling processes or ways of doing it, but that's just a quick example. If you chuck if a radio show says, "I want to know your views on like an extreme or like divisive topic," then you're quite likely to get people phoning in that have if they don't really care, they're probably not going to phone in. Whereas if they're like got strong opinions, that's when they're going to give them, and that might create bias because you're not getting everyone's views. That's just one example, but yeah, again, the questionnaire. Could you please take the time to fill this in for 5 minutes? Well, only certain people are going to do it, and maybe maybe they're like-minded, for example, and you're going to miss everyone else out. Um, you're always going to you're kind of always going to get a bit of bias because you don't. Well, how do you know that it's not biased? I suppose that's another question. But a bias can also occur from an incomplete sampling frame. If the population is a city of people, then just interviewing at a train station will result in bias. Yeah, that's slightly different to my radio show example. That's just looking in one place. You're only going to get one set of views. So hopefully you're happy with this. The idea that yeah, census is great, but actually you tend to not use them because you want to do things more quickly. That's not like shoddily, but these things, even a survey could take a fair bit of time. And yeah, there's key reasons when they work, like why you'd want to do it. The aim, of course, is to be representative at the end of the day. Let's take a look at an example then. This is a sort of thing you might be asked. For example, supermarket wants to deliver some avocados for ripeness by cutting them in half. Suggest a reason why the supermarket should not test all the avocados in the delivery. Okay, pause the video, have a think about that one. Well, it's the one with the exclamation marks. Okay, testing all of them meant we wouldn't be able to sell them. You don't tend to see half an avocado being sold, and there's a reason for that because they're gonna go off much quicker. The supermarket tests a sample of 5 avocados and finds that 4 of them are ripe. They estimate that 80% of the avocados in the delivery are ripe. Suggest one way they could improve their estimate. Well, the answer to this is always going to be to test more. You're only testing 5, so that's not great. You could take a larger sample, such as 10 avocados. It kind of depends how many are in the box. You don't want to, there's a balance, isn't there, between doing all of them and just doing a few of them. So you want a good idea overall and be representative of the whole population. All right, we've taken a quick route through populations and samples. We've talked about some different words. We've talked about different types of population and some examples of samples. We've then looked at advantages of censuses and surveys and done an example on that. Okay, let's look at one type of sampling method. More are to follow, but today let's just stick with one. And this is one that underpins lots of other ones. It's absolutely crucial. It is, I feel like I'm introducing like a wrestler or something here. SRS, it is simple random sampling. It is sometimes just referred to as SRS. And what this is you have your population. In this case, I've got people, I've got men, women, and I presume children. In this case, different people. And what we're going to do for simple random sampling is one of two things. Okay, if I've got 30 people in my population, maybe this is parents and children going to a nursery or something, I'm not sure. Then we could put all of their names in a hat or a number that corresponds with them. and then we could pick that name out. It's random. And then we could do maybe 5 out of the 30 to give us a sample of the 30. That would be quite quick to do, but maybe we'd get a feel for the whole population. You might argue maybe not for a nursery. Children and adults might have different views. Okay, but let's leave the nursery example and go back to maybe to avocados. We don't want to test every avocado. Maybe we test 5 out of the 30. So we randomly do 5 of them. Okay, but it's not like the first 5 we see. We actually do it more, in a more structured way. So if we do this in a hat, it's got a special name. It's called lottery sampling, but it is essentially putting names in a hat and picking them out. Another way you could do it is you could do it using technology, and you could generate random numbers. So there is a random number on your calculator, random number generator on your calculator actually. It is, where is it? It's somewhere. There's a little button. Here we go. You need to look for RAN with a little hash tag on your calculator. Press shift and that'll give you a decimal. So I just got 0.94. So, again, we could, instead of picking names out of hat, we'd have to somehow number these people and then do random numbers. Maybe again, they're just numbered 1 to 30, and I keep pressing random numbers, and you can keep generating random numbers. And the second random number I've come up with is 0.188. So maybe I just ignore the third digit on all of my random numbers and ignore the 0, and that would give me the 18th person. The next one, I've got 0.805, so I'd ignore that, it's too big. The next one, 0.271, so I'd ignore the third digit, ignore the 0, and I'd look at my 27th person. That's a very quick way of generating random numbers to help me create my simple random sample. Okay, some advantages and disadvantages. I want you to think about this, and then I'll tell you what I think the answer is. So an advantage to this sampling method is that everyone has an equal chance of being picked. That feels good, I think. It's not like your gym and you just got no chance of being picked. You got the same chance as everyone else. Kind of seems good, and it feels like you got a good chance of getting a representative sample at the end of the day. Some disadvantages, though. I mean, okay, it might still be difficult, expensive, or time-consuming to implement. If I want to pick everyone that lives in the UK and do a simple random sampling, well, first I need to get a list of every single person in the UK. I don't want to be writing their names down and putting them in a hat. That's going to take me the rest of my life probably. I could generate random numbers. Maybe I've got a list of them all, but that's going to be difficult to get as well. So there are issues. And it doesn't guarantee representation of all groups. Because of the probability side, maybe if I did it, then I would just, I don't know, ask all the men or all the women, or I'm biased towards the men. You just need to be aware of that because there is probability around it. So there are other sampling methods that try to cater for that, but that's for another day. Okay, so we're going to look at one example to finish, okay, of using simple random sampling. 100 members of a yacht club are listed alphabetically in the membership book. Okay, that is our population. The committee wants to select a sample of 12 members to fill in a questionnaire. So not all of them, just 12 of them. Explain how the committee could use a calculator or random number generator to take a simple random sample of the members. Well, I've kind of just spoken about that. Let's see, I am just going to show you the answer that I have. Okay, so we could allocate a number from 1 to 100 to each member of the yacht club, use a calculator or random number generator to calculate 12 random numbers between 1 and 100. That can be done using this button, or in some other button on a different calculator. Then you can go back to the original population and select them all. You've managed to do it. You could do it using an Excel spreadsheet or other random number generators as well. Explain how the committee could use a lottery sample. to take a simple random sample of the members. But that's when we could put all their names on identical cards. Yeah, there shouldn't be any bias. Shouldn't like Jim shouldn't have like this giant card with his name on that might make people tempted to pick it. Everyone's got the same cards, and then we draw 12 out, and that makes our simple random sample. I've said that it's possible to generate a simple random sample using lottery sampling, which is when you basically take names out of a hat, or by using random numbers. So this is an example of the latter, using random numbers to make a sample. And here I've just got sets of 5, and it's just randomly generated numbers. I'm not going to really talk about how they're randomly generated. You've just got to assume that they have been and that they're here. Now this could be a really big table. I've just taken the first 5 rows. And we can use this table to generate our sample. So let's say I've got test scores for a population of 100 students. Everyone gets assigned a number from 0 to 99. Use the random numbers to select a random sample of 5 students. Well, what we can do is we can just take the first 2 numbers to get my first person. So this would be number 36. That person would be asked we'd look at their test scores in more detail. The second person would be 51. The next person would be 83, then 67, and 77. And I've generated my random sample. Note if I happened, if I just kept generating them and I got 77 a second time, I would not worry about, I wouldn't ask that, look at that same person again, I would just ignore it. So basically, ignore repetitions. And it's great because we've got these 100 students. We don't have to use 3-digit numbers. We can just use this 00 here if that person did come up as the 100th person. So we can ask all of them. What I mean is we can just use 2 digits to potentially ask all of them, and any of them rather. Sorry. Okay. What about if we had 200 students? Well, this is a bit trickier. And the standard way of doing this is to now use 3-digit numbers. So I'm going to use 001 to 200. And I'm going to ignore the rest. I mean, I could do 000 to 199. Like, I can decide, to be honest, before I get my random numbers generated, I can decide 200 of these numbers that will define the population. So this time, my first number is 365, but I'm gonna reject that one because it's not between 001 and 200. My next number is 183. That's absolutely fine. My next number is 677. Nope. My next number is 789. I'm not going to write that one down, okay? I'm just going to use the ones that are meaningful. The next one is 116. And then I've got 55. Then I've got 422, which I ignore. 970, I ignore. 583, I ignore. 775, I ignore. Blimey, it's a lot to ignore. 163 is the next one. 927, 973, 62, and then 138. And again, I've generated a random sample. It's taken a bit more time, but there we go. In this case, sometimes people like to say, well, what if I just what if I say 1 to 200 and then 201 is back to being 1 and 202 is back to being 2? You can do that, but you just need to you have to be a bit more careful, I suppose. Like if you had 199 students, then you could do that kind of repetition aspect, but you'd have to not include the numbers right at the end. I hope that makes sense. But for our purposes in A-level, we're not really going to look at that. This is the sort of approach we're going to take. Okay, finally, there's a spelling mistake here. Okay, so I'm just trying to give examples. You might want to look at the relationship between humidity and rainfall in the year. You don't want to look at every single day, so you look at a random sample of 5 days, and then you're going to investigate that in detail. How can you do that? Well, have a think about this one after I've gone through the first two. Okay, this time I think it makes sense to use 001 to 365. We're assuming it's not a leap year, and then off we go. Same sort of thing. This time we can include 365, that's absolutely fine. We can include 183. We would ignore 677 and 789. So we take 116. We take 55, the 55th day. And then the 215th day. So there we go. That is an example of how you can use a table of random numbers to generate a random sample. Should just say one more thing. I've started with the first digit every time, and that kind of makes it, if I was to always use this table, for all my samples, then it wouldn't actually be random. So to maximize randomness, I could sort of actually just kind of close my eyes and point somewhere and say right, I'm going to start here. And actually the first one is going to be 162, then 249. Obviously the table would have to continue. So that's just how you could introduce another aspect of randomness into it. But for the purposes of A-level, I'd say just concentrate on the main, these sorts of questions, and then you'll be fine. But appreciate that, there are extra subtleties to it.